So welcome back guys. Let's start with the module 3, Subnetting and IP address maths. So let us go through the table of contents of this module. In this module we will be discussing subnetting in detail, that is how subnets are formed and what is the type of configuration that you need to do to form a subnet. We will study in detail the MAC addresses and IP addresses. We will discuss IP subnets, that is the type of subnets, local subnet and remote subnets. Then every subnet has a network ID. We will discuss how to calculate the network ID. And then we will discuss the IP arithmetic, that is the type of operations that we apply on IP addresses. And then we will discuss the point-to-point links and what is so special about point-to-point links. And then we will discuss the broadcast addresses and how to use the broadcast addresses. So in this module, we will take a deep dive in L2 and L3 routing. L3 routing means the routing that is done by the layer 3 of the TCP/IP stack, that is the network layer. L2 routing means the routing that is done by the layer 2 of the TCP/IP stack, that is the data link layer. So if you are appearing for the networking interview, 100% are the chances that you will be asked to explain the routing. So it is not possible that you appear for an interview at networking MNC like Cisco, Juniper, etc. The first question that you will be asked will be to explain the L2 and L3 routing. Right? So if you are willing to build your career in the field of networking, you must be absolutely thorough with networking concepts and especially L2 and L3 routing concepts. So you must be thorough with L2 and L3 routing concept. If you have any doubt, please revise and revise it again. L2 and L3 routing are not lengthy topic, but they are deep enough and it is the heart of networking. So entire networking just revolves around routing. Any other peripheral concept that you study in networking is directly or indirectly related to routing. There are hundreds of tutorials, YouTube videos all over the internet on this topic, yet I find students find it very confusing. So we will pick you from the absolute ground zero level and build up your routing concepts incrementally. We will do demonstration of actually routing a packet on the network topology, observe all relevant routing table entries. So let's begin with this module. So dividing a network into two or more smaller network is called subnetting, right? So the similar example that you can realize in real world is like dividing a country into smaller islands. For example, Mauritius Islands is a group of islands. Or dividing a high school students into groups or separate batches, right? So both of these examples are analogous to subnetting. In subnetting also, if we have a computer network which contains extremely large number of networks that become unmanageable over a period of time, then subnetting is one way to mitigate the management problem of large networks. A subnet is a layer 2 network. So remember, a subnet is a layer 2 network. That is, data link layer takes care of data transfer from one machine to another machine in the same subnet. So if the source machine and the destination machine are present in the same subnet, only L2 routing, that is layer 2, the TCP/IP stack, that is data link layer, is responsible to take the packet from source machine to destination machine in the same subnet. So as long as communicating machines are present in the same subnet, only data link layer is responsible for data delivery. The L3 layer, that is the network layer, is out of question. So if communicating machines are present in different subnet, right? In this case, the network layer is responsible to take the data from one subnet, that is the source subnet, to another subnet, that is the destination subnet. Now the point that you should note here is that network layer is responsible to take the packet from source subnet. This is source subnet. I am not saying source machine. I am saying from source subnet, that is the subnet in which where source machine is present, to destination subnet. Now I am not saying destination machine, but destination subnet, that is the subnet in which destination machine is present. So network layer is responsible to take the packet from source subnet to destination subnet, and not from source machine to destination machine. So this is a very sharp point about the network layer functionality to be noted here. So if the communicating machines are present in the same subnet, only data link layer is responsible for data delivery from the source machine to the destination machine. And if the communicating machines are present in different subnets, the network layer is responsible to take the packet from source subnet to destination subnet. And once the packet reaches the destination subnet, then again data link layer is responsible to finally deliver the packet to the correct destination machine. So once again you can see in this example that suppose the router VM wants to send data to the machine which has IP address 192.168.1.1 or to the machine which has IP address 192.168.1.2. Now you can see that both these IP addresses are present in the subnet 192.168.1.0/24. Let's call this subnet as A. Right? Now this subnet A is a remote subnet with respect to the virtual machine VM. Right? So if VM wants to send data to either of these IP addresses, it means the communicating machines are present in different subnets. Right? Machine VM1 is said to be present in subnet A with respect to the IP address 192.168.1.1. And machine VM2 is definitely present in subnet A. So this is the case when the virtual machine VM, that is the router VM, is trying to send the data to IP address which belong to the subnet A, and subnet A is a remote subnet with respect to the router VM. So in this case L3 routing will be used. But consider a case when the router VM wants to send a data to another machine which has an IP address 192.168.4.1. Right? Now, the IP address 192.168.4.1 is present in a subnet 192.168.4.0/24. Let's call this subnet as B. Now this subnet is a local subnet with respect to the sending machine, that is router VM. So the subnet B is a local subnet of the router VM, and VM is trying to ping an IP address which lies in the same local subnet B. So in this case L2 routing will be used for data delivery from router VM to router VM1. So I hope you understand the concept or the logic here. It all depends whether the IP address, that is whether the destination IP address belong to the local subnet or remote subnet with respect to a sending machine. So going forward, machines do not have IP addresses. So who have IP addresses? Only interfaces have IP addresses. Machines do not have MAC addresses. Only interfaces have MAC addresses. So it is technically wrong when we say that certain machine X has IP address blah blah blah. Machines do not have IP addresses. It is the interfaces of the machines which has IP addresses. And same is true for MAC addresses. right? So we always send data destined to a particular interface of a remote machine. We do not send data to a subnet. So this example is similar to like you are writing a letter to your friend. So you will specify the exact address of the house of your friend. You will not specify the town in where your friend lives. So same thing applies here. Whenever the source machine wants to send a data to some remote machine, the source machine has to specify the IP address of one of the interface of a remote machine to which it is trying to send the data, right? We do not send data to a subnet. It is meaningless. So you can see that this is the IP protocol header, or you can say in short, it is a IP header. The things to note in this header is that, see the source address. This source address is a 32-bit field. And you can specify the IP address here, but without any mask value, right? And similarly, this is the destination address field, which is again 32-bit field, and you can specify the destination address in this field, but without any mask value, right? And in IP header, the source address and destination address are specified in the form of integer equivalent. Integer equivalent. What is integer equivalent? Any IP address can be converted into its equivalent integer value, which is a 32-bit value. It is this integer value that we specify as a source address and destination address in the IP header. We will discuss later how this conversion is done.